So hello friends, welcome to my YouTube channel. Once again, I am back with an interesting question today. So in this question, a circle is given whose center is at point 4, 4 and we are asked to find the length of chord PQ. Also, we have the length of AB given as 3 units. So first of all, if the circle is having center at 4, 4, we can write that this will be 0, 0. This will be 8 comma 0, this will be 8 comma 8, and this will be 0 comma 8. Let this point be D, let this point be E, and this point be F. So first of all, the process will be like this. In step 1, we will find the equation of line BD. So we will find equation of line BD. After finding the equation of BD, we will drop a perpendicular from O on BD and let this point be M. In the second step, we will calculate the distance D, that is OM. We will find D. In step number 3, we will join Q and O, and of course OQ will be the radius of the circle and its length will be 4 units. So we will use Pythagoras theorem in triangle OMQ and we will find the length of MQ. After finding MQ, we will double this. So this will give us the length of chord PQ. So let us start solving it step by step. So the first is to find the equation of line BD. For that, we want the slope of BD. So slope of BD is equal to rise over run. So rise is 3 and run is this distance, that is 8 units. The slope of BD is 8 units. Now this line BD passes through this point 8, 8. So equation of line BD, I know that BD is a line segment because it has a starting point and ending point, but we can write like this also, equation of line BD. This will be y minus y1 is equal to m times x minus x1. Here x1 and y1 will be this point D, it will act as x1 and y1. So the equation of line will be y minus 8 is equal to 3 over 8 x minus 8. So we will cross multiply. So we will get 8y minus 64 is equal to 3x minus 24. We will rearrange. So 3x minus 8y plus this will be 40 is equal to 0. So this is the equation of line BD. So the first step is complete. Second step is to find this distance D. For that, we should know this rule that suppose we have a line and its equation is ax plus by plus c is equal to 0, and we have a point say here and its coordinates say for example are x1 and y1. We want to drop a perpendicular like this and we want to find this distance D. Then this distance D is equal to modulus of ax1 plus by1 plus c divided by square root of a square plus b square. In our case, a is 3 because this is the line 3x minus 8y plus 40 is represented by ax plus by plus c equal to 0. So from here a is equal to 3, b is equal to negative 8 and c is equal to 40. And what will be x1 and y1? It will be the coordinates of point O. because this is the point from where we want to find the distance. So we will have x1 as 4 and also y1 as 4. Let me make some space for finding the distance. So D will be equal to A, that is 3, times x1, x1 is 4, plus B is negative 8 times y1 is also 4 plus 40 inside modulus divided by square root of A square, that means 3 square, plus B square is negative 8 square. This will be 12 minus 24 plus 40 inside modulus divided by square root of 9 plus 64. So let us use calculator. 12 minus 24 plus 40 will be 28. So this is 28 over, this will be square root of 73. So the value of D is 28 over square root of 73. I know that we can rationalize the denominator and it will become 28 root 73 over 73, but we will leave the value of D as it is. Let me again erase and make some space. Now let us focus in triangle OMQ because our step 2 is also complete. In OMQ, we will apply Pythagoras Theorem and we will try to find the length of MQ. So MQ square will be equal to OQ square minus OM square. So MQ square will be equal to OQ is the radius, so square of 4 minus OM is D, so this will be 28 over root 73 whole square. So we will use calculator. 28 over root 73 squared, and we will subtract from 16. So this will give us 384 over 73. So MQ will be square root of this value, which will be 8 root 438 over 73, and in short this will be approximately 2.3 units, the length of MQ. Now we know a theorem that if we have a circle, this is the center of the circle, and say for example if we have any chord, from the center of the circle if we drop any perpendicular, then this will be the bisector of this chord also. So the same theorem we can apply here. From O we dropped a perpendicular OM on this chord PQ, so M will be the midpoint of PQ, so PM will be equal to MQ. So MQ is known to us, approximately 2.3 units, so PQ will be equal to double MQ. So 2 multiplied by 2.3 is approximately 4.6 units. So we have successfully found the length of chord PQ. If you like this video, do subscribe to my channel. See you in the next video.